Assalamualaikum. Hi guys. Let's continue with the second subtopic about equilibrium constant. In this video, I'm going to teach you how to define the homogeneous equilibria and heterogeneous equilibria. And after that, we are going to learn how to write the expressions for equilibrium constants in terms of concentration, Kc, and partial pressure, Kp, for both types of equilibria. So, in the previous video, you've learned so far about law of mass action where it's stated like this one. You know that if you got this kind of equation in your question, what you should do, you have to write the expression for equilibrium constant. The first thing first, at equilibrium, and then you got the expression for K equals to concentration for all products raised up to its power over the concentration of reactants raised up to its power. And you can see that this is how you write the expression for equilibrium constant. But what I want you to emphasize here, the equilibrium constant can be expressed in two forms actually. The first one is Kc in terms of concentration, and the second one is Kp in terms of pressure. So when you want to write the Kc, you should only write for all species in aqueous or gaseous phase. While for Kp, it is only for gaseous species. Sebenarnya equilibrium constant ni dia ada unit, tapi unit dia akan berubah mengikut situation. So for your syllabus, matriculation level, we standardize where you have to treat Kc and Kp as dimensionless quantity. Maknanya dia ada value tapi tak ada unit. And the next one, you should know that Kc and Kp are temperature dependent, where different temperature will have the different value for Kc and Kp. Dan juga last one, you should not include any species in solid and liquid dalam Kc-Kp expression. So now I'm going to teach you what is the definition of homogeneous equilibria. It means that the chemical equilibrium in which all the reactants and the products are in the same phase. Contoh saya ada based on this example, all of them between reactants and product got the same phase for all of them. So, how to write the Kc for homogeneous equilibria? Secara general, this is how you want to write it down. You have to make sure that you got the phases for all species in the same phase. And then, bila awak write it down, awak akan nampaklah bahagian concentration dekat atas untuk products dan bahagian concentration di bawah untuk reactants. Ini secara general, tapi beza dia kena tambah huruf C untuk indicate in terms of concentration. For example, I have this one. First thing first, you have to make sure your equation is balanced. So, saya dah lihat ada 2 nitrogen dan 4 oxygen for both of them, reactant and product. So, when I want to write my Kc, saya akan letak product with its coefficient sebagai power. So, I'm going to write it down where saya ada concentration NO2 square over concentration N2O4. So, Kc dekat sini adalah equilibrium constant in terms of concentration. Dan square bracket, ingat kita guna specifically untuk concentration. Let's try next example. So, how to write this one? Make sure you balance the equation first. So, saya ada 2 sulfur, dan I have 4 plus 2, 6 oxygen and 6 oxygens. And then when I want to write the Kc equals to product saya ada SO3, so concentration SO3 square over concentration SO2 square times with concentration O2. So ini adalah jawapan dia. So same goes here. If I want to write the Kc expression for this equation, letak dulu concentration for your product over dengan concentration of your reactant. So, cara yang paling penting, pastikan awak balance the equation. Now, settle for Kc, kita go for Kp expression. Kp expression dia adalah untuk in terms of pressure. So when you write it down, you have to put Kp huruf P dekat bawah ataupun kita panggil subscript, you have to write it down as this one. Partial pressure for your gas raised up to its coefficient. And then the top one adalah untuk bahagian produk, and then bahagian bawah adalah untuk bahagian reactants. So bila awak tulis equation, awak perlu pastikan awak tulis letter P untuk indicate partial pressure in ATM for your gas. Okay, now we are going to try to write it down the Kp for this one. Ingat, Kp only applies for gases species sahaja. So dalam kes ini saya ada both of them dalam phase gas. And then saya dah check equation already balanced. So I will have partial pressure NO2 square over partial pressure N2O4. So itu cara sebut dia. This is how you got the answer. Next one, saya ada this one. Equation sudah balanced tapi saya nak write it down in terms of partial pressure for the equilibrium constant. So start with the product. Kita gunakan kurungan bulat dekat sini ya. Kurungan bulat sebab kalau awak gunakan kurungan petak, it is wrong for Kp sebab kotak square bracket dia adalah untuk concentration. So get back to this question. I got partial pressure SO3 square over partial pressure SO2 square darab dengan partial pressure O2. So that's how you write it down. Let's try one last equation. So how to write the Kp for this one? The equation already balanced. So I'm going to put the product at the top and the reactant below it. Dan dalam kes ini, awak kena take note that equilibrium constant expression iaitu KCKP expression are also called as equilibrium law expression. So this is another term for KC and KP expression. So kita dah settle untuk bahagian homogeneous equilibria. Now I'm going to introduce to you about heterogeneous equilibria. This is where chemical equilibria in which the reactants and product are present in more than one phase. Contoh saya ada example 2 where this is my equation. I have reactant in solid phase reversible with one of the product CaO in solid phase dan another one more product CO2 in gas phase. So bila saya nak write the Kc, usually saya akan include this one. Tapi ingat, species in solid and liquid phase kita tidak akan include. So that's why only concentration for gas and aqueous sahaja yang akan appear in Kc. So maknanya species yang ada dalam phase solid ataupun liquid tidak akan masuk dalam expression kita. So I will cancel out CaO dan CaCO3. Yang tinggal untuk Kc adalah concentration CO2 because CO2 is in gas phase. Seterusnya, same goes for Kp. Kp hanya untuk gas. So, kita akan consider bahagian CO2 gas here untuk bahagian Kp. So, that's why saya ada Kp equals to partial pressure CO2. So, let's try this example. You have to write the KCKP expression based on this equation. So saya check dulu dah balance ke belum. Saya ada 1 nickel both side and then saya ada 4 carbon and 4 oxygen atoms both sides. So what we're gonna do right now, we have to write the Kc. Ingat, Kc untuk gas dan juga solid sahaja. So contoh saya ada gas for this one, saya ada gas dan ini adalah solid. So, satu benda yang awak kena faham, because we are not included solid or liquid in KCKP expression because concentration of pure solid and liquid remain constant because dia akan retain the same number of mole per liter of the solid and liquid. So, kalau dia bertambah pun ataupun dia berkurang, nilai dia masih lagi sama di mana kita akan guna nilai dia adalah 1. Constant untuk solid dan liquid. Sebab tu tak masuk dalam KCKP expression. So get back to this question. Example 3 dia minta awak write the expression for Kc and Kp. So untuk Kc, I have my product at the top and reactant at the bottom. Seterusnya, kalau saya nak write untuk Kp. So for Kp, this is how I write it down for partial pressure of NiCO4 over partial pressure CO dan 4 kat sini. This 4 kat sini adalah untuk tunjuk koefisien dekat depan. So saya harap awak jangan tertukar. This 4 is equal. Okay, and then this 4 adalah untuk this one. So that's how you write the KC-KP expression. Sedikit summary untuk part this one. You should know how to write the equilibrium constant in terms of KC and KP, di mana apa yang diberikan adalah cara yang general untuk write the expression. Dan ingat, macam mana untuk KC kita hanya tulis for species in solid and gas. How about KP? KP only for species in gaseous phase sahaja. So, sedikit summary juga apa yang kita sudah belajar dalam bahagian subtopik ini. Yang pertama tentang KC dan KP. Awak perlu faham there is no units for KC and KP because they are dimensionless. Contoh saya ada this one where the value for KC is 1.67. Saya tak tulis unit tapi saya wajib tulis temperature dekat tepi. Same goes for KP. Seterusnya, benda kedua yang awak perlu belajar adalah di mana KC-KP is temperature dependent. So, dia akan bergantung kepada temperature. So, sebab itulah bila kita write the answer, KC and KP kena tulis dalam kurungan the temperature given for that question. Next one, kita juga belajar macam mana concentration of solid and liquid tidak termasuk dalam bahagian equilibrium constant expression because untuk gas dan aqueous only for KC, untuk gas sahaja only for KP because concentration pure solid dengan liquid do not change much with temperature. Kita akan assume dia nilai dia 1. So, contohnya saya nak jawab soalan this one, KC-KP dalam case calculation. So, how do I want to start? Saya keluarkan dulu information. Based on my information, saya ada this is the equation. And then I have the value for KC. And then I got the concentration of NO2. Seterusnya the volume is this one. Dia minta awak determine the mass of N2O4. The first one, untuk dapat markah, awak akan tulis dulu expression untuk KC. So, awak ada expression untuk KC, this one. And what's next? You are going to continue by substituting the value for KC here. And that equals to the concentration of NO2 you got from the question over dengan concentration N2O4. So, bila kita rearrange for the concentration of N2O4, I will have 0.1208 molar. Tapi, soalan minta mass untuk N2O4. So, daripada molarity, kita akan calculate dulu number of mole di mana I insert all those value. Saya akan dapat number of mole untuk N2O4 is 0.273 mole. Now, barulah saya boleh gunakan mole ini darab dengan molar mass untuk dapatkan mass of N2O4. So, you have the final answer is 25.136 gram. Dan kita akan cancel out unit mole dekat sini, yang tinggal adalah gram sahaja. So, you got the final answer. So, that's how you show the calculation part for KC and KP. I leave it to you, try this 1.0 and the next one try this 2.0 and the last one try this 3.0 for you to complete this question. Final answer saya dah beri, boleh buat satu rujukan apabila awak dah attempt this exercise. So that's it from me. I will see you in the next video. Bye.